This is a problem from lesson 9-2. This is number 20 on page 473. And I'm going to show you how to find a confidence interval for the difference of two means. Large samples, although you'll notice the sample size, one of them is actually less than 30. But because we know the standard deviation of the populations, we can still use our z-distribution, our z-test, our z-score to do this problem. So again, normally if we had a sample size less than 30, we would not be able to use z, but we are going to because we know the population standard deviations. Here's the problem. Two brands of batteries are tested and their voltage is compared. The data follow. Find the 95% confidence interval for the true difference in the means. Assume that both variables are normally distributed. So we're going to do the 95% confidence interval. 95% confidence is going to help us figure out our z-score. "95% confidence" means 95% of the area is in the middle of the distribution, meaning that our alpha value, our area on the outside, would be 5%. If we take that 5% divided by 2, so alpha would be 0.05 in this case, divide by 2, this area would be 0.025, this tail area would be 0.025. Meaning that each of these areas, and again we could just take 0.95 divided by 2, or we can do 0.5 minus 0.025 to get 0.475 here and here. Then we can look this area up in a z chart and we can come up with our critical values, our z-score here and here, which come out to 1.96 for our right critical value and negative 1.96 for our left critical value. And you also may have a chart of some type back if you maybe have a chapter 7 formula sheet around. It may also tell you that a 95% confidence interval uses critical values of 1.96 and negative 1.96. So those are going to be our z-scores right here. Z sub alpha over 2 is going to be negative 1.96 and positive 1.96. And you can see the plus there and the minus there. All right, let's go ahead and work through the problem now. We've got these two different brands of batteries. The sample mean of these 27 batteries of brand X, sample mean is 9.2 volts. So I'm going to put a 9.2 right here, minus the sample mean of brand Y, our second group, 8.8 volts. Minus our z-score, which we just figured out was 1.96, times the square root. Our standard deviation of our first population is 0.3, so you're going to have 0.3 squared over our first sample size, which is 27, plus our second sample standard deviation squared, or excuse me, population standard deviation squared, 0.1 volts squared over our second sample size, 30. That's going to give us the left answer on our interval. And if we work it out, this comes out to 0.4 minus this amount right here would be your error, your maximum error of your estimate, how far you're going to allow yourself to be off of 0.4, and you can see the difference between these is 0.4. So, and if you type this into your calculator, that comes out to 0.119 if we round to 3 decimal places. So 0.4 minus 0.119. Over here, we'll end up with, if we plug all the same values in, and again, notice that we're doing a confidence interval for the difference of the two means, mean 1 minus mean 2, population mean 1 minus population mean 2. So we're trying to predict the difference in the voltage between the two different brands for all batteries, not just the sample size. So if we plug all those exact same numbers in, I'm going to plug all those exact same numbers in here, except for instead of a minus in front of that z-score, there's going to be a plus. If we type them all back in again, we're going to get 0.4 plus 0.119. And I'm not going to write all these out, but it would be these exact same numbers. So we're going to have here, we would have mu1 minus mu2. On the right side, we would have 0.4 plus 0.119. And if we do this subtraction, and then we can round to the nearest tenth because our data was given to us at the nearest tenth. So if we really be just taking 0.4 minus 0.1, if we're rounding to the nearest tenth, this would come out to 0.3. 0.3 volts would be the label. Is less than mu1 minus mu2 is less than, and if we were doing 0.4 plus 0.119, that would be 0.559, 0.519, which would round to 0.5. So we are 95% confident that the difference in the average voltage of the batteries, all the batteries in brand X, compared to all the batteries in brand Y, there's a difference of between 0.3 and 0.5 volts. We're 95% confident of that. And we know that if we're getting a positive answer here, that mu1 must actually be larger than mu2, because if we get a positive answer when we subtract, that means our first number is larger than our second number, right? If we do a subtraction and the first number is smaller, then we would get negative answers. So in this case, and we can see that from our data too, that our sample mean was larger in brand X. So brand X, we are 95% confident that brand X has between 0.3 volts and 0.5 volts more voltage